And let's write y equals b to the x exponent. Okay. If we were graphing that, notice there's no a in front, right? Do you remember what we said a was when that happened? 1. So if we were graphing y equals b to the x, it would go through the point 0, 1. And if we put 1 in for x, it would go through the point 1. And then I don't know what b is, but whatever it is. Like if it were 2, it'd be 2 to the first is 2. If it were 5, it'd be 2 to the 5 to the first is 5. And then it had a horizontal asymptote of y equals 0. Agreed. Okay. So we're not graphing exponential functions though, but I'm going to use that graph to graph a logarithm function. So I'm drawing a line here. This is the line y equals x. Think back to geometry. If you would reflect this curve over the line y equals x, I hope you can see it would come down here. I'm not drawing it yet, but it would come down here. Okay? That's all a logarithm graph is. And so you kind of got to think about that. And then let's reverse everything. This is what the graph of y equals log base b of x would be. Or another way of writing that is x equals b to the y. I'm switching my x and y around. Okay. Can somebody tell me, if I reversed my x and y's around, can somebody tell me what would be 1 point on my new graph? So if 0, 1 was on the exponential function, what point would be on the inverse? What do you think? What do you think? I think you know. 1, 0, yes. We reverse the x and y's around. So instead of going through 0, 1, all logarithm graphs, guys, every single one of them before you do transformations are going to go through 1, 0. Now we're going to do transformations and things with them, but they will. All right. Also, this goes through the point 1b. So Anthony, what should the new graph go through? B1. I don't know where B is. It's somewhere over here, but I'm going to go up 1. So also all logarithm graphs, once you figure out their base, which it should be right there for you, they're going to go through the ordered pair of whatever their base is, comma, 1. Okay. Prediction time. On an exponential graph, it had a horizontal asymptote. If I switch that, where do you think the asymptote would be on this? Let me give you a hint. This is really the line y equals 0. So what do you think the asymptote would be on the new graph? X equals 0. It's a vertical asymptote right here. So now we draw our nice smooth curve. It looks just like that. And by the way, just try to make this arrow approach the vertical asymptote, but it never reaches it. How we doing? Okay, let's talk about our new graph then. What are some things about our new graph? Have you seen this graph before? Yes? No? Okay. So, some things that we should talk about. Let's run through the domain and range and symmetry and all of that. I hit on this on Friday, but logarithms, you cannot put negative numbers in, and actually you can't put a 0 in. So the domain for logarithms is you have to put something bigger than 0 in. So you're going to want to make sure, if I'm writing it as an interval, it's 0 to infinity, or you could write x is greater than 0. Does it look like there's any restrictions on the range? It looks like this goes down forever. This is going to increase forever, albeit slowly, but it is going to increase forever. So the range on logarithm functions is negative infinity to infinity. Just like an exponential function, this is an increasing function. It's increasing on its entire domain. So I would say it's increasing from 0 to infinity. Does it look like it has any symmetry to you? By symmetry, I mean even or odd, or neither. Does it look like if you flipped it over the y-axis, it's the same? No. Does it look like if you rotated 180 degrees, it's the same? You can even do that. No. So this does not have any symmetry. And it has no extrema either. So it doesn't appear to have any maximums or minimums. Finally, what does it appear that it has as an asymptote? We talked about this. What kind? Vertical or horizontal? Vertical at x equals 0. Okay. Okay, so just so we're clear, I'm going to just sketch here. If I said to you to graph y equals log base 3 of x. Just want to make sure we're understanding this. What I want to see on my graph is 3 things. This is all I care about. I want to see the point 1, 0. What's the base of this log? 3. So it's going to go through the point 1, 2, 3, 1. And then I want to show that it has this vertical asymptote here. So I draw a nice, smooth curve like that. Okay. Let's do one with transformations. Let's sketch a graph of y equals log base 5 of x minus 2 parentheses plus 1. So my question is, how is this related to log base 5 of x? Can somebody give me one thing? What does this do? I heard it. It moves it to the, which way? Just point for me, guys. Moves it to the right 2. What does this do? Which way does that move the graph? up 1. So what I would be looking for then on this is, I think it's helpful to sketch the original and the new graph. So this is the original graph. The log base 5 of x goes through 1, 0 and 5, 1. So 1, 2, 3, 4, 5, 1. And it has a vertical asymptote of 0. So my new graph. Let's move my new graph right to. Where would this vertical asymptote go then? Over. Okay, so let's draw our new asymptote. Let's move this point right 2 and up 1. So I go over 2, 1, 2, up 1. That point would move up to there. The point 5, 1, I move right 2, up 1. And I sketch my new curve. Okay, if you're unsure today as you're going through what transformation rules, because you forgot, I would be happy to